Okay, concept 32 deals with solving systems of equations. This is part one of elimination. There will be a second video for part two. So the elimination method of solving systems of equations is also called the addition method. And we're essentially adding two equations together. So when we do this, our goal is that we transform the system of equations such that one of the variables cancels out. And we'll see that in a few examples in just a second. But we want one of the variables to cancel out so we can solve for the other one. So our steps are first that we're going to add the system in order to eliminate one of the variables. And then we eliminate one of the variables to solve for the other variable. Now, in some cases, both of the variables will cancel out at the same time. So there are pretty much two pathways we have when that happens. So when they both cancel out, either we get a true statement, which means there are infinite number of solutions, or we get a false statement, which means that there are no solutions. So it just depends on what you get. Now, if only one of the variables cancel out, and we solve for the variable that we have, we then need to substitute the value of the first variable found into either equation to get the second variable. And then our last step would be to take our two coordinate points, x and y, and write them as an ordered pair, as a coordinate point. So let's take a look at a few examples. In the first one, I have these two equations, and I need to add them together. So I want you to consider, like, when you add vertically, you're just adding whatever's whatever's lined up, right? So if I were to add 2x and negative 2x, that's actually 0, right? Those are opposites of each other, so they cancel out. They go away, so which is good. This is what we want. And I have negative 3y, negative 2y, I get negative 5y. And then I leave my equal sign there, and I get negative 15 and negative 10, and that's negative 25. Now I have an equation that I can solve with a simple with a simple operation. Since I'm multiplying negative 5y, negative 5 times y, I can divide by negative 5 to get rid of it. So y is equal to negative 25 divided by negative 5, which is just 5. So I've found one variable. I eliminated the x to find the y. Now I need to go back into either equation to find my x. And to do that, I'm going to, I'll pick the first equation. So I have 2x minus 3y is equal to negative 15. Now, again, I know what my y is, so I'm going to replace or substitute my y for 5. Now that I have substituted that variable, I can solve for x. So I'm going to do a little bit of simplification here. I get 2x minus 15 is equal to negative 15. And I'm going to add 15 to both sides to get the x by itself. So I end up with 2x is equal to 0. From there, I know that I can divide by 2 to get my x by itself because I'm multiplying, and x is equal to 0. So our final point is 0, 5. 0, 5. And that's what we want. So this essentially represents the fact that these two equations that we started with are lines. When you graph them, they create lines. And we're trying to find out the point where they intersect on the graph. And that point that we found algebraically through the elimination method is they cross at 0, 5. They intersect at 0, 5. And just to show you, in the steps up top, it said that I could substitute into either equation. If I were to pick my second equation instead of my first and do the same process, I want to show you that we're going to get algebraically the same answer. So again, I take my second equation, I substitute my y for 5. So I get negative 2x minus 10 is equal to negative 10. I add 10 to both sides to get the x term by itself. And then I have negative 2x is equal to 0. And to get rid of the negative 2, I again divide. And x is again equal to 0. So either way, whichever equation you choose, you're going to get the same answer as long as you do your steps properly. Let's take a look at another example. In this scenario, I again have this step where I have this system and I want to box out the terms that look alike, and I want to combine them. So negative 4x and 4x is 0, and 2y and negative 2y and 2y is again equal to 0, and 6 minus 6, or 6 plus negative 6, is 0. So I get both variables canceling out, they go away, but this time I get 0 equals 0. And since this is a true statement, I know that there is an infinite number of solutions. In other words, I can plug in any numbers, or there are multiple pairs for x and y that I could plug in to get the correct answer, to make it fit into my system. And in the previous example, we talked about the idea that when two lines are crossing, they meet at a given point, and that point was 0, 5. In this example, I want you to see that what's happening is that these two lines are identical. This one and this one are identical, which means that if I were to graph one line that looks something like that, maybe the other line would sit right on top of that line. So it's the same exact line, and they're going to be intersecting an infinite number of times. That's why we get infinite solutions. We'll try again with another problem here. Again, we are going to box out my numbers, my terms. So I'm going to combine. I see that my y's cancel each other out, and I get negative 6x and negative 5x is negative 11x, and negative 13 and negative 9, negative 19 and negative 3 is equal to negative 22. From here, we need to divide by negative 11. So x is equal to 2, which is cool. So now we need to go back and plug it into either of our equations to get the result that we need. So since I know my x is equal to 2, I'll pick my first equation as an example. And I'm going to substitute my x for 2. Like this. So I get negative 12 plus y is equal to negative 19. I need to add 12 to both sides to get rid of this negative 12. And my y is equal to negative 7. So our final point is 2, negative 7. And you could pick your second equation if you'd like, and you're going to get y is equal to negative 7 as well. So that's it. You're finding the points where they intersect. We will do another one together, our final one. So again, I want to cancel out or box out these answers, these terms. So negative 8x is negative 16x. 8y and negative 8y combined or added is 0. And negative 24 and 8 is actually negative 16. So when we go to get rid of the negative 16 here, I also have to do it on the other side. I have to divide, I have to do the opposite. X is equal to positive 1. Cool. So we need to then take our x and plug it into our other equation to solve for y. And again, I'll pick the second one just because we picked the first one before. So I'll take my negative 8x minus 8y is equal to 8. So now I have negative 8 times 1 minus 8y is equal to 8. So this is negative 8 minus 8y is equal to 8. I need to get rid of that negative 8, so I'm going to add 8 to both sides. So then I get negative 8y is equal to 16. I then need to divide by negative 8 on both sides. And y is equal to negative 2. So my final point that I need is 1, negative 2. Okay? And that is part 1 of elimination.